Hello, how's it going? My name is Michael Farrell. This is my Nashville Software School Data Analytics Capstone project. It is a menu management and cost per meal dashboard. Currently, I'm an assistant director at Vanderbilt University Campus Dining. So this project is pretty relevant to my everyday. Also, this is going to be an automated dashboard presented in Power BI. All right, so let's get into it here. My agenda, I'm going to talk about my mission, go over some light definitions to bring some context to what we'll be talking about, my motivation and data question, a high-level overview of my workflow, a tour of the actual dashboard, some of the technologies I used, and what I might be doing differently moving forward. All right, so my mission. I feel passionate about being able to provide actionable data as quickly as possible to people who can make the biggest impact. And the audience to this dashboard would be frontline dining management, floor managers, general managers, and chef managers. Those are the operators that I'm going to be referring to and have the ability to make the biggest impact from this dashboard. All right, some definitions. We have NetMenu. That's our menu management software. It's the software that we buy raw ingredients with and transform them with recipes. And then sell them as finished goods to our customers, as well as put them on a customer-facing website with nutritional information. Gold is our card service software. So anytime you go into a dining hall on campus and tap your ID badge at a POS station, it registers taking a meal plan. So we are going to be looking at that information. We have cost per meal. That is the total cost of food on the menu divided by the number of customers that come through the door. So if we have a menu that is going to cost us $1,000 and 100 people come to eat it, our cost per meal will be $10 per person. We have a forecasted amount in cost. That's an educated guess on amounts to produce. We have a prepared amount in cost. That's the amount that got recorded for production in a real setting. The served amount in cost, that's the difference from the serve that was prepared, how much of the food was actually served. And then we have a leftover amount in cost, and that's going to be the difference between the prepared and served amounts. Okay, the main data question. You know, the food service business moves so fast, and large-scale dining operations like this are very nuanced, and there's oftentimes a lack of follow-up with available information. The real goal of this dashboard is to be a frequently visited page by the operators where they can adjust their production. This will live in their web browsers as a bookmark page. They're going to be able to visit it each and every day and adjust production behaviors from it. In my time at Vanderbilt, I was on the team that led the implementation of this menu management software. And sometimes the lack of feedback it was able to give to our operators was always something I wanted to improve upon. In my time at NSS, as I was learning about how all of the different systems and the different processes and different technologies could be used, I often thought about how they could be implemented in the workplace and saw this as a especially low-hanging fruit that could serve an immediate impact, especially as those operators navigate unknown forecasting and unknown menu item changes as a result of the pandemic and product shortages. So the motivation, real-time data and to shorten the feedback loop. You know, we have a core line of business software that does not allow for automation, and this project identifies an opportunity to shorten that feedback loop for enhanced operational effectiveness. Shift managers who look at this information are going to be the ones to be able to make the biggest difference for that production. All right, so how am I doing this? The business day happens and end-of-day processes are run and email of those CSVs are sent. I just triggered that right before this presentation. Power Automate is going to move those CSVs to a local file, and then using a couple of different Python libraries, the information is ingested and parsed, the data is cleaned, calculations are performed. Using the OS and glob libraries, I was reading in entire folders, performing those calculations and cleaning, and then concatenating those files together and appending a larger file in a different folder, all in a timed manner. And as that was happening, Power BI is refreshed via an on-premises data gateway to get pushed to the web environment for that front-end user. So let's take a look at the dashboard itself. Okay, before I bump out into full screen here, I want to just point out over here on the dates, we have 1, 2, 3, 4, 5, 6 days, and we're going to be looking at an entire week. So let's refresh. Bam, there's our 7th day. Okay, like I said, this is our date slicer to analyze which day we're going to be looking at. Underneath of it is our service course slicer. The service course is the actual station within the dining hall where people choose to get their meal from. Oftentimes in large dining halls like this, we don't have every single station open at one time, and nor do people go to every single station that's open. So this slicer allows for the operators to bump up stations against one another that might be open at a single time, or to isolate stations to analyze their performance. And that ties in with the meal period slicer, because sometimes these service courses are open for more than one meal period, so we're able to identify, the performance of the specific meal period or time of day. Jumping down from that, we have a table that has the date, some hard-coded numbers that the operators provide about how many customers they think, or how many meal plans they think they're going to do in that given day. And then we have the actual numbers that's supplied by gold. So you see here, the operator thought they were going to do 11,055, actually did 10,138, and so we missed the forecast by 917 meal plans. And that number is reflected here on this card, and the number is in red as they missed their forecast. If they had exceeded their forecast, it would be in green. Moving from that, we have our clustered column chart, the prepared cost, served cost, and leftover cost. That leftover cost column is simply the difference of the prior two columns. So you can see how much they prepared versus how much they served. This serves as a really good gauge, a quick gauge to see if their high production days coincide with their high meal plan days. Moving on from that, we have our top 10 highest cost leftover item. So you see for this breakfast menu, the highest cost leftover item, that item that was really driving our cost per meal there, was our crispy cube breakfast potatoes. All right, and then looking at our chef table, coming up here to the main card, we have a CPM, that being cost per meal, and goal cost per meal by service course. So for the chef table of this week, it's saying 74 cents. What that's saying is our total prepared cost for this week at the chef table divided into the total meal plans we came out with 74 cents per customer. Whereas we had a forecasted cost on this menu divided by the 11,055, and it should have been 59 cents per customer. So you see here we missed our goal by 15 cents. So that's something that, that figure is something that's highly analyzed, and really the best way to quantify large performance in large dining halls like this, or production performance in large dining halls like this, when you're serving such a varied menu. We also have our leftover cost per meal. That is our leftover amount divided by the number of customers that we're doing, and then our leftover cost from a prepared cost. So we have our leftover costs bumped up against our prepared costs at 5.6% in this instance. All right, jumping over one tab. This is more meant for frontline production staff. All of these slices are the same here. But we have our forecasted amount, prepared amount, and served amount represented on the clustered column chart. So you can pretty easily tell that for this breakfast menu, they forecasted too much every day, or more than they actually needed to serve every day. So there's some opportunity that could be gleaned from this about how much should actually be forecasted, or that would drive their pre-cost per meal, and that we really missed it on this last day of the week. Also, we have our top 10 highest quantity of leftover items. So this is how many of these items were actually left over. You can see where those leftovers occurred at by clicking on those different food items. If I was a manager here, I might bump this out into a table and give this information directly to my service staff as some opportunity to curb overproduction in the coming meal services. All right, so that's the dashboard. I'm going to jump back to my deck really quick, talk about some of the technology I used in order to automate and get this get this on this Power BI dashboard. Like I said before, I use the OS and glob libraries for reading in entire folders, and then the schedule and time libraries in Python to set up the automation. That OKViz custom slicer was the slicer I used for the service course. You can see the emblems of the other technologies I used for the dashboard. Power Automate and the on-premises data gateway we didn't really get into in the NSS program, but they definitely serve their place here for this dashboard, and I feel like I can add them to my repertoire now. They're super handy tools to use. Okay, well, what might I do different moving forward? I would have the automation occur in a cloud computing environment so that automation wasn't dependent on a specific machine. This process could also be run more than one time per day. Say this was a 24-hour restaurant and we wanted to run this process every 6 or 8 hours. We could do that. For those cards at the top of the first page of the dashboard, where it showed a leftover a cost of leftover per meal, and then leftover as a percentage of production of the produced amount, I would also incorporate waste data as well as purchasing data if this was a internal document just at Vanderbilt to use. This is very much a dashboard for my NSS Capstone, but if this was more of an internal document, I would include that information there as well. And finally, I want to thank all the food service staff who actually generated this information, and to Vanderbilt Campus Dining for helping me and partnering me with my capstone. Thank you.